over the past several years, we have seen dozens of energy disaggregation papers. All of them have been on the premise that of Lord Kelvin's famous quotation that if you cannot measure it, you cannot save it. But despite all that effort, there remains little evidence showing that if you can measure, are you actually saving energy or not? So in this work, we are going to explore the opposite of what Lord Kelvin had proposed, that if you can measure it, can you actually improve it? Traditionally, when we talk about the feedback which NILM research comes up with, so it's something like a pie chart, or the eco feedback which we come as the energy itemized breakdown. It might tell you that your fridge is consuming, say, more than your neighbors, but does that really empower you to save your fridge energy consumption? Probably not for an average user. What we actually need is like actionable feedback so that people don't only know about their energy usage, but they can also do something about it. Let's take an example. So here we see two fridges, or fridges from two different homes. The top one is a regular fridge, whereas the bottom one has something weird going on. It turns out that the top fridge has a single high-powered state, whereas the bottom one has multiple instances of this high-powered state. Actually, this is due to the fact that the bottom, So this is due to the fact that the bottom fridge has much more defrost going on due to the fact that the seal is broken. So it ends up consuming 30% more energy than it would have done if the seal was properly repaired. So this is the kind of actionable feedback we want to give in this work. So when we talk about giving feedback, the basic approach we take is that instead of stopping at the power trace or the energy trace, we look at certain specific features from the power trace, such as the length of the duty cycles or the actual power value of any given appliance. I'm going to focus mostly upon HVAC and fridge because firstly, they are found in most of the homes and they consume more than 60% of an average American household. The way I'm going to evaluate our work is we'll start with appliances and we'll assume that we have some metering sensor, something like the power blade sensor, which many of us might have seen at Census a couple of days back. And based on the trace, the true appliance level trace, we extract features to provide actionable feedback. Next, we use the same feedback mechanism, but instead of using some metered sensors and the actual power traces, we use energy disaggregation methods to break down the aggregate signal into different appliances. What we really need to answer at this stage is, do disaggregated traces provide those actionable feedback? And this is the prime question which we're going to answer throughout this talk. Fridge, as we all know, is a very simple appliance. All of us have it. It's a compressor-based appliance where the compressor duty cycles on and off periodically to maintain the fridge at a given set point temperature. But there's way more to it than the simple graph that we saw previously. Every now and then, the fridge goes into something known as a defrost cycle. So this is the time when the heater of the fridge turns on, and it removes the excess frost. So apparently, this is needed to keep the fridge going at a higher efficiency. But for every defrost cycle, we see that the next few compressor cycles also have an defrost introduces heat into the fridge, and you then need to keep the compressor on for longer duration. And whenever you're using fridge, that also ends up just opening and closing, keeping groceries, keeping warm food, or kids just having fun in the home. Now, this is an actual trace taken from a home. So this is how a 24-hour trace would look like. In the night hours, you would have typically very low usage, unless and until you're a night animal or you're hosting a party. So the fridge would be, we call such usage as baseline usage. And we calculate the baseline duty percentage of the fridge as the median of the duty percentage throughout the night. So using the median gives us this advantage that, say, if one of the days, one of the night, the defrost turned up, our approach will still not get affected. When we're talking about defrost energy consumed in the defrost state, and secondly, the extra energy which is consumed, which is the extra heat which has to be removed. Talking about usage energy, so this is all the extra energy over and above the baseline usage. We use the Wiki Energy dataset, which collects data from a large number of homes in Texas, and specifically Austin and other cities. And we have data for 97 fridges and 58 HVAC, for which we'll try and give you some actionable feedback. So once we have broken down the fridge energy defrost and usage, it turns out that we can use outlier detection methods. In this plot, we can see the homes which should be getting feedback based on high amount. These red homes, where very high number of cycles are actually affected by, have some kind of active usage going on. So all these homes, or some fridge etiquettes, they can save up to 1/4 of their fridge energy. But it turns out that if instead of using sub-meter traces as the plot below, if we were to use 3 different NILM algorithms, the accuracy of feedback that we get is rather poor. We can see that all these red homes, which should have ideally been in the green zone, getting the feedback based on the traces produced by different NILM algorithms. And there are they end up getting feedback. Similarly, for defrost, we find out homes which have more than 2 defrost cycles per home. Clearly, something wrong. But when we try to do the same thing with NILM algorithms, it turns out that NILM algorithms even make a plot to show how poorly how the feedback would have fared for. Interestingly, it turns out that when we use these benchmark NILM algorithms, the same which were used to better or at least comparable with the state-of-the-art accuracies on conventional NILM metrics such as error in energy. So the question really is that despite getting good accuracy on conventional NILM metrics, why are we faring so poorly in terms of the metrics we care about or in terms of giving actionable feedback? It turns out that you can predict good, even predicted the fridge consumption something like this. But the important features which we care about incorporate a trace like this, and the features the usage events. And NILM algorithms. Coming on to the HVAC, it's again a very fact that it also duty cycles, and it tries to maintain the space at a set temperature. But as the outside temperature increases during the day, the compressor cycles also increase in the duration, because now you need to turn on the compressor for longer duration to remove all that extra heat which the environment is injecting in. And by the way, when I'm talking about HVAC, I'm assuming that we are in a hot climate, and this is the summer months. So you want to cool your homes. And it also turns out that when people use their HVAC, when people leave their homes, they might increase the temperature so that the HVAC does not consume a lot of energy when they're not at home. So then you would have compressor cycles of shorter durations. In fact, it's a set point schedule for different hours of the day for programming. The goal is to be able to find homes which are not adhering to. We decide to give feedback based on a scoring mechanism where the score varies from 4 to 0, 4 being the most energy efficient home. The way we compute this score is like for each of these segments, we find how much above or below the recommended schedule is the score. For instance, during sleeping hours, the minimum recommended temperature is 82 Fahrenheit. If our temperature is more than 82 Fahrenheit, we give a score of 1. If it's below, say, 78 degrees, we give a 0. Anything in between, we give a fraction. So we really need to be learning we really want to be learning the HVAC set point to provide this kind of a feedback. The way we do is that we weather usage and the amount of energy that is being used. And so we use a non-linear regression model with the weather information and the HVAC trace. When we talk about giving feedback to these homes based on scores, we use these learn set points, and we also use certain other features from the HVAC trace to be able to find out homes which don't need feedback and homes which actually need feedback. Coming to the results, it turns out that we get a very 4% in terms of the number of homes which should be getting or should not be getting feedback when we're using the sum-meter traces. But when we use the NILM methods, the part traces produced by NILM methods, it turns out that the accuracy drops by about 15 to same plot conventional metrics. We find out that performing comparable or better than the state of the art. Still are we doing so bad in terms of the feedback? It turns out that one of the important features was the number of minutes. So this makes sense because in the morning time, you want your HVAC to be turned to a higher temperature so that people, when people are leaving for their offices, they don't consume a lot of HVAC energy. It turns out that for the night hours, the error in prediction of minutes of HVAC usage is pretty low. In the morning, it's pretty high. So in the night, it's only the HVAC and the refrigerator which are typically being used, and you get good accuracy in predicting HVAC usage. But in the morning, you have all the appliances, toaster and other appliances working simultaneously, and thus on the disaggregation for the morning hours. But it turns out that in Texas, we get good accuracy in terms of the conventional metrics. To conclude, we started with the question of whether if we can improve if we are measuring it. It turns out that we can actually improve if we are measuring it, at least given appliance level data traces. And we saw that we can get up to 84% accuracy in terms of identifying homes which need HVAC feedback. And we also were able to find out homes which need feedback based on fridge defrosting too much or fridge being used too often. But it turns out that our results are showing contrarily that we really need to measuring the progress of the NILM community, because do not provide the valuable features which we need for providing actionable